Welcome. So this question says an organ pipe is open at both ends. The organ pipe is 5 meters long. Assume the speed of sound in air is 330 meters per second. And it's saying what is the wavelength of the second harmonic and what is the frequency of the second harmonic. So for this I'm going to draw the organ pipe, and then I'm going to imagine drawing a wave inside. And we don't try and draw, it's hard to draw compressions and rarefactions, so what we tend to do is we tend to kind of cheat a bit, and we draw it as if it was a transverse wave. So we have, compressions and rarefactions, and I think of it as that's like an antinode, because things are wiggling a lot backwards and forwards, and that's an antinode. And that's the kind of rule for the organ pipe open up both ends. You can't have a node at one end when it's open. It's not allowed. So this is the simplest. Structure I can imagine. Wave mode I can imagine. If I go to the next complexity, again I have to have a normal mode on each end. I have to have an amplitude, antinode at each end, and the diagram that will give me that is this. That's the next most complex way of drawing this. Again, we have a antinode and an antinode, and it turns out there's another antinode in the middle, and then node here and node there. And if I go to my third diagram, then I can have and this is an antinode at each end, and then I have two antinodes in the middle. So we had no antinodes in the middle, then we had one antinode, now we have two antinodes. So that kind of reinforces the idea that this is a good progression. If you think about it, this is very much like the opposite of what we had before. Simplest for a guitar string. If I look at this, it's the same pattern. This was a node and a node with no node in the middle. This is an antinode and an antinode with no antinode in the middle. This is a node with a node with a node in the middle. And this is an antinode with an antinode and an antinode in the middle. And this is a node with a node with a node with a node. A node on each end and two nodes in the middle, an antinode at each end and two antinodes in the middle. So these are analogous to each other. So I would expect a kind of similar analysis when I try to figure out what's going on. So an organ pipe that's opened at both ends behaves very similarly to a guitar string in terms of its harmonic sequence. So we say, well, L is equal to, well, that looks to me like half a wavelength. I'm interested in the second harmonic, so there's my first harmonic, it's the simplest pattern. Then here's my second harmonic. Now, a second harmonic, not because it's the next complicated pattern, but because the frequency is twice as big. And this is my third harmonic. I'm interested in my second harmonic. So for my second harmonic, this is an entire wavelength. So L is equal to 1 lambda. So lambda is equal to L, which equals, in this case, 5 meters. So there's my first bit. And then for my second bit, again, I'm going to say V is equal to F lambda. So F is equal to V over lambda. So F is equal to V, and V in this case is 330 over lambda, and I just worked out that lambda was 5. So that would equal 66 Hertz. So here we have it. We have 5 and 66 Hertz, so my two answers. It's a very similar analysis to the standing wave on a guitar string. It's just it's analogous to it. And here we've done the second harmonic.